let's summarize what we can get from a converging double convex lens. It does not have to be double convex, but it has to be convergent. Okay, to do that, let's go back to the simulation. The first case is when we have an object placed far away from the lens, further than twice the focal length. In that case, as you notice, our image is inverted, real, and diminished or smaller than the object. Now, a practical application of that, think of images of objects we look at through our eyes, at the back of our eyes on our retina, so they have to be small to fit on our retina. Another example, an image on the back of a camera. Okay, that's an application of that. Large object, small image. Now, if we place our object between twice the focal length and the focal length, then we get an enlarged real image. It's an enlarged, real, and inverted image. Now, the closer I get to the focal length, the larger the image gets. Examples of that: a projection screen. You put a small slide and then it projects it into a big picture. The last application is when we have our object closer to the lens than the focal point. In that case, we get a real upright image that is inverted. In that case, we get a virtual image that is upright and enlarged. See, the closer we get to the focal length, the more enlarged it gets. This is the principle of a magnifying glass. Now, going back to the principal rays that we use to figure out the image that is formed by a lens, I'm going to do it by hand here. Rays that are parallel to the principal axis pass through the focal length at the other side of the lens. So a ray that's parallel to the principal axis, it's going to go through the focal length, in the other side of the lens. And then rays through the center, continue straight. And then rays passing by the focal point come out parallel to the principal axis. All rays are going to meet where the image is formed. Now, the assumption here that I didn't mention earlier, this applies for monochromatic or light at a single wavelength incident on a thin lens. The rays have to be all near the principal axis, not a huge lens. Otherwise, these approximations for the rays would not hold solid.